horrific. Now, it's so horrific I tried to work it out first, and I finally arrived at an answer. I'm not going to do all of it because it's way too long. Just want to show some principles here. Diagrams show a quadrilateral, pentagon, hexagon, all with the possible diagonals that can be drawn in, have been drawn in. So for example, four-sided shape, 2 diagonals, there it is. 5-sided shape gave me 5 diagonals, if I put a 5 there. A 6-sided shape, I've got 9 diagonals, trust me, I've counted them. For a 7-sided shape, I've got 14, and for a 8-sided shape, I didn't bother to do it. But let me show you how to get a sequence out of that. This is really hard, so let's have a look. I have got to use my table to predict the number of diagonals in patterns having 9 sides, etc, etc. Well, let's get a sequence going here. 2, 5, 9, 14 so far. What have I got? Plus 3 from there to there, plus 4 from there to there, plus 5, so from there to there, plus 6. 14 plus 6 is going to be 20. So for my 18s, I've got 20, then plus 7 for the 9 sides, so 20 plus 7, I'll get 27 there, plus 8 for my 10-sided shape, plus 8 would be, how far do I get up to? Plus 3, 4, 5, 6, 7, 27, plus 8, ooh, I don't know, 30, plus 8 onto that, 35, plus 9 onto that, 44, plus 10 onto that, 54, I think that's right. Yeah, that'll do. I'm getting tired. Right, add on 7, add on 8, add on 9, add on some. Yeah, I'm really happy. Right, that's not the difficult bit. The difficult bit is use your answers to find the formula, in other words the nth term, which gives me the number of diagonals for polygons with n sides. In other words, I've got to relate this number here, this 4, to number of diagonals, this 5 to number of diagonals, this 6 to number of diagonals, that 7 to those number of diagonals, etc. And it's really, really tricky. So let me try and unravel this a little bit. It's quite involved. In fact, for this reason, I want to get this out of the way. If you'll let me. No, I can't move it, never mind. So let's just try to do it like this. Alright, so these are the diagonals. That's the diagonals, and these are the number of sides. So I've got, this is my n value. So here I go. I've got 4, 5, 6, 7, and 8. So if I go up one at a time like so, I find that the second level I'm adding 1 on each time. If you remember from the previous videos, straight away I've got an n squared rule. Now if that goes up in 2s, it's just a 1n squared rule. If it goes up in 4s, it's a 2n squared rule. But it's only going up in 1s, so it's a half n squared rule. So straight away, the number of sides, if I square it, then halve it, I should get down to my number of diagonals. But I don't, so I need to do a little bit more to it. Now look, let's change to black. Now, let's just try this out. 4 squared is 16, halved is 8. Alright? So 5 squared is 25, half of that is 12.5. 6 squared is 36, half of that is 18. 7 squared 49, half of that is 24.5. 8 eighths are 64, half of that 32. So I've got to relate the 8 back down to the 2, the 12.5 back down to the 5, the 18 back down to the 9, and help use that to somehow finish off this very difficult sequence. Now this is what I noticed. If I multiply my 4 by 1.5, this is barely going to show on here, I get 6. If I multiply my 5 by 1.5, I'm going to get 7.5, 7.5. If I multiply by 6 by 1.5, I'm going to get 9. If I multiply by 7 by 1.5, I'm going to get 10.5. Now, I'm getting closer and closer. Can you see that if I take away 8 and 6, I get 2. If I take away 12.5 and 7.5, I get 5. If I take away the 18 and the 9, I will get 9. If I take away 24.5 and 10.5, I will get 14. And I want to stop there. Basically what I'm doing, I am taking away 1.5 lots of n. Let's just say that again. 4 times 1.5 is 6. 8 take away 6 is 2. 5 times 1.5 is 7.5. 12.5 take away 7.5 is 5. Therefore, I've found the second part of the sequence in a way by trial and improvements. Alright, you have to tinker with these numbers, play with them. There's no easy way to do this, not with something that difficult. Alright, so my sequence is half n squared, derived in the normal way, minus 1.5 n's. Now let's just try it out, see if it works. First we'll have a dirty great blue around that, and we'll keep it there safely. Let's just try it out. If this works, then I know I've got it. Let's try it with the 8, because I've not used it at all in the calculation. So let's just try it with that one. Again, I've not done this yet. I'm going to try and work up here. So if I take my 8 and I square it, so I go 8 squared, then I halve it, and then I take away 1.5 lots of 8. Hopefully I will get 20. Well, let's have a look. Well, 8 squared is 64. Half of 64 is 32. Now minus. 1 lot of 8 is 8. Half lots of 8 is 4. 8 plus 4 is 12. 32 take away 12, and to my great relief, I get 20. And I'm so tired of this question, I'm not going to possibly going to do another trial. Try it yourselves, alright? So n square, halve it. Take away 1.5 lots of your n, and you will get a relationship linking the number of sides to the diagonals, the maximum number of diagonals possible. So I could call it d equals for diagonals and put a little d up there to show the examiner what I'm doing, but that's it, and that's horrific. Now what follows next is dead easy in comparison. I think I've lost one of my photos. Let's have a look. No, that's done, that's okay. Diagonals, that's good. No, it's just a blank page. Well, here's an easy question for you in comparison. Let's have a look. I'm going into the assess now, and that is, yeah, I really want to do the exam question. It's a lovely question, links lots and lots of algebra to sequences. It's the AQA exam style question, and that's in the assess, and I'm on page 22, and this is rated at grade B. Now I think it's a little bit tougher than that, but still, let's go for it. We'll work in black. Now it says in a sequence the next term is made by taking the last term, subtracting 1, and then squaring the result. So here are the two adjacent terms in a sequence. So it starts with p, and then it says I subtract 1, so p minus 1, and then I square the result. Okay, so I'm just like keep going with that if I wanted to, but I don't. It says show that the next term along can be simplified to, get ready, it says bracket p, another bracket, p minus 2, close the bracket, and then square that result. So I've gone from there to there and there to there. What did I do? I took away 1 and then I squared it. Well, basically I've got to do the same to this thing here. Take away 1 and square it. Tougher than it looks, and I should arrive at that answer if I get it right. I will get it right, and let's work in yellow, nice and bright. So I've got p minus 1 squared. Well, first of all, let me just untrap that. I've got p minus 1, get it all out into the open, multiply by himself, that's what squared means. P times p, well that's p squared. P times minus 1, put arrows there, is minus a single p. Minus 1 times p is minus p, and minus 1 times minus 1 is plus 1. Simplifying, I get p squared minus 2p plus 1. What have I got to do next? Okay, I've just multiplied that out and expanded it and simplified. The rule says I've now got to subtract 1. Okay then, so if I'm going to minus 1 from that, that will become p squared minus 2p. And then what have I got to do? I have got to square the result. In other words, I've got to square this. Oh, fair enough, let's do it. Yeah, okay, let's do it straight away. So here I go. I've got p squared minus 2p all squared. I'm going to have to break it open, I think. Or, better still, I can factorise this a little bit, because look, p's come out of the bracket. So I've got p, taking it out of the bracket is p minus 2. Let's just check it. P times p is p squared. P times minus 2 is 2p. And then I can square the entire thing, and because it says so, and I arrive at the original question at my